All right, this is Algebra lesson 10.2C, right? Isn't that where we're at? 10.2C, yes. The final day we're going to go over this. Okay. Let me show you, let me go over everything once, just one quick time. If I said this, the absolute value of 80, and I asked you to simplify, not absolute value, the square root of 80, and I asked you to simplify that. That means we're going to pull out what we can, right? We're going to make this a simpler problem. Here we go. What do I do? 80, you break it down into the square root of what? 8 and 10, you could, sure. You could do 2 and 40 if you want, right? It doesn't matter. 8 and 10 is the square root of 4 and the square root of 2, and the square root of 2 and the square root of 5. The square root of 4 is a good one because you know you can just pull out 2 because the square root of 4 is 2. So there, we're pulling out a 2 there. 2 comes out. And then you go, the square root of 2 times square root of 2 is 2. So times 2, right? They're gone. And then the square root of 5 is all by himself times square root of 5. So it's 4 times the square root of 5. You all should know how to do that, right? What about this? What happens when we have this? It's like the square root of 2 times the square root of 14. This one's already been, you could go 2 times 14 is 28. So you could say the square root of 28. Right, you could go square root of 28, and then you break it down into the square root of 2 and the square root of 14. Well, that's dumb, right? Does that make sense? But you could do that, and there's times that you may want to do that to make things simpler, but in this situation, don't. Break this down, square root of 2 times square root of 7. What is the square root of 2 times square root of 2? 2 times the square root of 7. When do you know for sure that that's done? When do you know that you can't do it anymore? When it's prime, right? When it's prime. Right? Question? Can you combine them into 4 and 7? Sure. Square root of 2 times the square root of, what was it, 14? Well, I mean, how would you get there? How would you get there? So you'd have to go, that's fine, and then you could do that, but it's the same number of steps, right? It's all, you know what I'm saying? Like, you've already broken this down. Why put it back together? You can, if you want to. It's just more work. Okay, and then here's this, a big one, square root of 90, x to the third, y to the fourth, z to the fifth. You pull out 90, and so it's the square root of 9 times the square root of 10. Square root of 9 is a good one because it's just 3. Pull that thing out. Square root of 10 is the square root of 2 and square root of 5. You can't do anything with that, agreed? So then it's just 10 stays in here. X to the third, what can I pull out there? I can pull out 1x, which x squared, right? So square root of x squared, I pull out an x, and I leave an x in here. Now when I pull out, that is a single x that I've pulled out. That means I have to absolute value it, right? Y to the fourth, what times itself is y to the fourth? Y squared. Do I have to absolute value that? No, because it's even. That's gone. And then z to the fifth, I can pull out z to the squared, right? I pull out z squared. And I'm using with a z in there. Do I have to put an absolute value on the z squared? No, because it's even, right? So we're done. Does that make sense? That's the review that we've done so far. There's one more type of question, and that is this. If I have the square root of 4 fifths, right? Square root of 4 fifths. What can I do? What do I have to do here? I say simplify this. You have to. That's the same thing as the square root of 4 over the square root of 5. Agreed? Okay. We should look at this and go, wait a second, you recognize square root of 4 is 2. So it's 2 over the square root of 5. Can I be done? It looks simplified to me. Can I be done? No, why not? What's the rule about being simplified? The denominator can't have us be square rooted, right? It's just the rule. It's just like, why can you not have in a function, well, here's the deal. Let's talk about it. How can you possibly put that in a calculator if whatever it is 2 divided by, and then 2 divided by what? What could you put in there? There's nothing to put in. You see what I'm saying? There's no way to enter it. So you can't divide it by an irrational number. The irrational number can't be on the bottom. Does that make sense? It just can't be. You can't divide it by that number. So anyway, so what do you do then? How do I get rid of this? Square root down here? Multiply it by 1. Remember, you're allowed to do anything you want to a fraction. You can multiply any fraction you want to by 1 in whatever form you want to. It's just got to be by 1. By me multiplying this by square root of 5 over the square root of 5, I'm not changing that at all. You understand what I'm saying? I'm not changing that at all. I'm multiplying it by 1. I'm just kind of manipulating it to make it into the pie is still the same amount of pie. I'm just cutting it into whatever pieces I want to. That leaves me with what? What's the bottom going to be? What's the denominator going to be? 5. Square root of 5 times square root of 5 is that, and then 2 times the square root of 5 is the top. And I'm done. Make sense? Okay. The last one. Now we get to the new part for today. A conjugate. Do you remember this? Do you remember what is A plus B times A minus B? Do you remember what this turns out to be? What does it end up turning out to be? Well, what am I going to do here? How can I solve this then? If I gave you this and said, I want you to simplify this, what would you do? You'd go, what would you do? What would you call? FOIL, right? I'm sure somebody said that. FOIL. A times A is A squared. A times negative B minus AB, right? B times A plus AB, and then B times negative B minus B squared. Do you agree? Right? What happens here? They're gone. Minus AB plus AB, they're gone. So then it ends up being A squared minus B squared. Remember, that's the difference of squares. Right? That's the difference of squares. Remember that concept, that here's the deal. Whatever I have, when I have AB, if I want to turn that into a difference of squares, what would I multiply AB by? What would I multiply A plus B by? I would multiply by A minus B. Does that make sense? Okay, so just remember that. So what if I have this 5 minus X, and I want to turn that into a difference of squares? What would I do it? I would make it be 5 plus X. Does that make sense? I would multiply it by 5 plus X. We'll come back to that. Just remember that concept. Here we go. If I have this 3 over 5 plus 2, 5 plus the square root of 2. Now here's the deal. How in the world, remember, are you allowed to have a square root as a denominator? No, he's sitting there like that. How do I get rid of that square root then? Since I can't multiply both the top and the bottom. Look, if I multiply both of this by the square root of 2 times the square root of 2, what's that going to do? Now I'm going to do the rainbow, and I'm going to go, and now it's going to be 5 times the square root of 2 is still on the bottom. Do you see what I'm saying? And that's still no good. Do you see where that's no good? I need you to all see where that's no good. You can't multiply this when it's like this. When it's like that, I cannot multiply that by the square root of 2 over square root of 2, because when I rainbow it, that first one, 5 times, now it's still 5 times the square root of 2. I have nowhere to go. That didn't help. So what you do is you're going to multiply this thing by 1 in the form of its conjugate. In the form of its conjugate. What would turn this into a difference of squares? You'd multiply this thing by 5 minus the square root of 2 over 5 minus the square root of 2. Do you agree that that is still 1? Anything over itself is 1, right? So now let's do this. Try to remember. A plus B times A minus B. We know this is the difference of squares. So do I need to do FOIL here? What does it end up being? What does this end up being? We did it already. A squared minus B squared. So then, what is this going to end up being? 5 squared minus 2. Listen, remember, it was A plus B times A minus B. This ends up being A squared plus B squared, which means that this is going to end up being 5 squared, not plus, minus, sorry, this is a minus, which means this is going to end up being 5 squared minus the square root of 2 squared. Do you understand what I'm saying? Notice that, what's the difference, right? This is A squared minus B squared, which means that this is going to be 5 squared minus the square root of 2 squared. What is the square root of 2 squared? 2. right? So it'd be 5 squared minus 2. What is 25 minus 2? 23, which now we've gotten rid of that square root down here, yes? Right? So the denominator is now 23. Let me write it out though. It ends up being 25 minus 2. That's the denominator. The numerator up here, what do I do here? This is 3 times this, so it ends up being square root, right? I'm not square root, rainbow. 15 minus 3 times the square root of 2. Do you agree? Okay. 15 minus 3 times the square root of 2 over 23. Can I reduce anything here? I can't do that because that's 3. That 3 is being multiplied by the square root of 2. Does that make sense? So I can't subtract that. Can I reduce 15 and 23 or anything? No. Guess what the answer is? Right there. And if you look in your text, page 614, look in that example 5, that's exactly what they have. 15 minus, so this is ugly. Do you agree that answer is ugly? Just follow the rules though. Just follow the rules. If you only know the tools you're allowed to use, this is it. I can't do anything else with this. I can't do any more. It's done. That's the answer. That is the answer. You guys try one. 3 over 2 plus the square root of 2. Try and do it. You need to understand, this is not difficult. It's just a matter of you don't know it. So here we go. What's the rule? If I say simplify this, what do you look at and go, there's the problem, there's the issue, there's the thing I need to do? You see the square root as the denominator. Okay, we have to get rid of that. If this 2 wasn't here, if that 2 wasn't there, what would I do to get rid of this square root on the bottom? Multiply by 1 in the form of square root of 2 over the square root of 2. Right? Okay. But there's not. There's a 2 there. So I can't just multiply this by the square root of 2. Let's try. I really want you to see this. Okay, so I'm going to multiply this thing by the square root of 2 over the square root of 2. What that means is that it's going to be the square root of 2 times 2 plus the square root of 2. What is 2 times square root of 2? 2 times the square root of 2 plus 2. We still have this as the denominator, which still has a square root. Make sense? Okay. So we don't do that. When you have a binomial down there, do you agree that it's a binomial down here? Do you agree that's a binomial? Do you agree that that's a binomial? Right? What's a binomial again? 2 monomials, 2 terms, right? Okay. When you have a binomial down there, we have to multiply this by, what's it called? Its conjugate, right? Its conjugate. So, by 1 in the form of its conjugate. What is its conjugate? 2 minus the square root of 2. So I'm going to multiply this by 2 minus the square root of 2 over 2 minus the square root of 2. We already know how to do this without doing FOIL. If you need to do FOIL, that's fine, but that's going to take you twice, 3, 4 times as long as anybody else who knows that this is going to end up being the first term squared. So that would be 2 squared, and then minus, you know it's a difference of squares, this thing, the second term squared, which is the square root of 2 squared. What is the square root of 2 squared? 2. What is 2 squared? 4. So it's 4 minus 2. The bottom is now 2. Okay, the top is 3 times this. Rainbow. What is 3 times 2? 6 minus 3 times the square root of 2. Can something be reduced? No. It cannot. Remember, the only way that you can reduce this is if you can also reduce this. If you can reduce this. It's no different than I can't reduce this. Isn't this just using the if you're going to do this, aren't you using the distributive property? Well, in order to use the distributive property, you have to distribute it to everything. right? So if you can't reduce both, then you can't reduce this. Does that make sense? So you can't reduce this because you can't reduce this. Remember, when you do that, when you start reducing here, you are using the distributive property in reverse, right? You're dividing, or you're actually multiplying by a half. If you can't do it to everything, then you can't do it. That is our answer right there. Does that make sense? Did anybody get that? Did anybody try and make that 3 minus 3? Did anybody get that? Yeah, see, that's wrong. You thought you pulled out a tool and you're like, oh, cool, I can do this, and you weren't allowed. Does that make sense? So you aren't allowed to do that. It's important that you understand that. Even if it's not in this particular lesson, remember, you cannot divide this unless... Now listen, what about this? Why am I allowed to do this? Why can I reduce... I better draw that neater so we're no confusion. Why am I allowed to reduce those? It's just, they're like terms, and it's just a monomial and a monomial, right? It's two monomials. On the top of my desk there, you'll see the rest of them, Mrs. Campbell. So listen. You're up here. I'm allowed to do this because let's break this thing apart. This is x over x times y over 1. Do you agree that those two are the exact same? They are the exact same, right? That's why I can reduce them. They're gone. Over here, with this one, what would this be equal to? This is x over x plus y over x. Does that make sense? X over x plus y over x. Is that true? Right, that's true. I can't get rid of this x here. I can't get rid of this x because, look, this is 1, I agree, but you're still, the x has to stay down here. Does that make sense? I mean, I can't get rid of this guy completely. Anyway. Okay, let me give you another one. 7 over 3 minus the square root of 7. Come on now. You can do it. I'm telling you, where this is going to be it. You better get it quick. All right, here we go. We're going to multiply this by what? What's it called? What's it called? 1 in the form of its conjugate. 3 plus the square root of 7 over 3 plus the square root of 7. Yes? Right? Did everybody get to this point? I mean, does everybody know that that's the thing you do? I'm serious. Does everybody here know that that's the thing you do? Raise your hand if you know that that's what you do. You multiply by 1 in the form of its conjugate, and you understand what a conjugate is. Okay, so now that we're here, I'm confused. We're going to multiply. You know how you multiply fractions, right? You multiply the tops, and then you multiply the bottoms, right? Let's multiply the bottoms. We chose this. So we know this is the difference of squares. We chose the conjugate. So we know it's going to be the first term squared. What is 3 squared? 9. And we know it's going to be a minus because it's a minus times a plus, which is a minus. And then we know that it's going to be, what is the square root of 7 times the square root of 7? 7. We know that. Do I need to do FOIL again to show you that that's true? Or can you guys just remember that that's what you do? We've done this. This is like chapter 8. The top. You have to multiply the top. You put this thing in parentheses and you do rainbow. What's 7 times 3? 21. What is 7 times the square root of 7? Plus 7 times the square root of 7. Okay. 9 minus 7 is 2. 21 minus 7 times, plus 7 times square root of 7 over 2. Can that 2 be reduced by everything up there? No. Therefore, we are done. How many of you got 21 plus 7 times square root of 7 over 2? Does it make sense? Try another one. 4 over 6 minus the square root of 7. This is the last one we're doing. Last one, watch carefully so you make sure you have it. I'm going to multiply this by 1 in the form of its conjugate. 6 plus the square root of 7 over 6 plus the square root of 7. The denominators are going to end up being the first number squared. What is 6 squared? 36. Minus, why do we know it's a minus? I don't even need to look at this. Why do we know? Because we chose the conjugate. We chose it. Right? Square root of 7 times square root of 7. Up here, we have to now multiply the numerators. Put it in parentheses. 4 times 6 is 24 plus 4 times the square root of 7. What is 36 minus 7? 24 plus 4 times the square root of 7 over 29. And we're done. How many of you got that? Still no? Okay. I'm going to give you guys your homework. Well, I'm going to do one really quick here. I'm going to have you watch me do one. Hardest one on the page. You're just going to watch this one, though. 5 over square root of 6 plus the square root of 3. Okay, so here's the deal. This is the tricky part. Ready? There's no tricky part. What do I do with this? Can I add square root of 6 plus the square root of 3? Can I add them? Why not? Why can't I add them? You treat square roots very much like you would treat it as though they were a variable. If they aren't identical, you can't add them. Does that make sense? Listen, if I have the square root of 5 plus the square root of 5, you know what that is? That's 2 times the square root of 5. Just like if it was x plus x, what would that be? 2x. Does that make sense? If I have the square root of 5 and I add a square root of 5, I now have 2 square root of 5s, right? Does that make sense? So the only way you can add these guys is if they have the exact same, if they're the identical, which they are not. So watch. I still can turn this into, I can't have the denominator have any square roots. So what am I going to multiply by? 1 in the form of its conjugate. Square root of 6 minus the square root of 3 over square root of 6 minus the square root of 3. Do I need to FOIL this or do we know what to do? What's the numerator going to be? What is the square root of 6 times the square root of 6? 6. What's the minus? What's the square root of 3 times the square root of 3? 3. Over, rainbow, rainbow, 5 times the square root of 6 minus 5 times the square root of 3. So it's 5 times the square root of 6 minus 5 times the square root of 3 over 3. Make sense? Just because things are a little different, the rules don't change. Right? All right. Your homework. This is Thursday? Oh, right. I'm making this up myself. I forgot. Okay, so this is page 615. You are going to do numbers 11 through 16 all, and '43 through 48 all. It's about 10, 11 questions. It's not that many. This is due tomorrow.